So I had come up with the idea for making adjustments to the center of gravity of a rotorcraft by sliding the main gearbox and drive system on rails on the fuselage. Now, the reason we'd want to do this is really twofold. It gives us enormous increase in the flexibility in the way we can operate the aircraft. So, for example, we can put our fuel in the rear of the aircraft, slowly burn the fuel off, and not alter the performance and handling of the aircraft, because we can just alter the CG in response. The other main benefit is that when you are using the vertical bark capsule, right? So Pochari Technologies, excuse me. So sliding center of gravity system for electric drivetrain rotorcraft to eliminate limitations faced by weight and balance requirements in conventional rotorcraft. Electric power is provided by our dual-chamber diesel-free piston engine. We've gone over that already. 4.5 horsepower per pound Magnax axial flux motors are made in Belgium. They're around 4.5 horsepower per pound of 4,000 RPM. A linear hydraulic actuator provides sliding actuation. This innovation allows for greatly enhanced mission flexibility as a result of the wider CG range allowable, and is especially complementary to our VD technology. When a load is picked up in the VD capsule, it's ideal to have the CG directly over the center of the capsule. Once the capsule is retracted, the load can be transferred to the fixed fuselage section on either side of the capsule. And then, as this occurs, the CG is slowly shifted to either side until perfectly balanced. The implications for sliding center of gravity are enormous. As fuel is burned during flight, the CG changes. Gotta fix that with the system. The fuel tanks can be placed in the rear of the aircraft rather than underneath the bottom of the fuselage, as centering the fuel mass is no longer necessary. Attack helicopters can store munitions outside of the CG range without concern of shifting CG as ammunition is consumed. Utility helicopters, cargo, or passenger-carrying aircraft can carry the load outside the CG range by simply shifting the CG position. The CG sliding range is designed to be between 20 and 24 inch for an 8,000-pound Bristol aircraft. The rail, the length of the desired CG range, constructed out of carbon fiber, is lined with a metallic liner. On this metallic liner, a high-friction rubber liner is also placed. A mechanism connecting the drivetrain module on the rail allows for sliding and locking of the location. Multiple small rollers retract from the rail slide mechanism. Once the rollers retract, a friction pad is extended, providing a tight connection between the friction pad in the rail mechanism and the high friction liner on the rail. The system has gone through feasibility analysis and found to add negligible additional weight and well worth any additional technical hurdles considering the immense performance gains. So, that is the stick. The idea may sound radical to conventionally minded people, but some guy in Germany came up with the idea as well because, well, it just makes so much sense. So here's his drawing. As you can see, he plans on sliding it, looks like a pretty considerable distance. In the case of a helicopter comprising a rotor system with rotor blades held on a fuselage and at least one rotor shaft, and furthermore comprising a drive system for causing rotation of the rotor system together with the drive system, of course, is able to be slid in the longitudinal direction of the fuselage. So owing to the longitudinal displacement of the rotor and drive system in relation to the fuselage, the center of gravity of the helicopter is so changed that the helicopter is inclined about its transverse axis forward and respectively backwards, so the foreflight may be accelerated and respectively retarded. Okay. The control of the center of gravity of the helicopter of the invention leads to a significant saving in weight and operation of the rotor with less vibration. The helicopter furthermore responds extremely rapidly to corresponding changes in the center of gravity, so the extremely precise and simple control of steering of the helicopter is possible. Okay. This is very, very, very important. This is exactly what my invention allows. Now, of course, as you know, the entire point of vertical embark technology is enhancing the operating scope of the aircraft, but as we can see right here, if we are picking up a very heavy load in the capsule, we ideally want our rotor disc to be directly over the center of mass of the capsule. Then we may place a significant load. We may be dropping down our capsule, picking up a load, loading up the fuselage, and doing that a few times over. And each time we do that, we require a shifting in the CG. So this is a very radical innovation that is not only complementary to VED, but just provides enormous increase in the versatility and flexibility of the rotorcraft.